Hello and welcome to today's video. Today we're going to be doing 1249 minimum remove to make valid parentheses. So given a string of parentheses and lowercase English characters, we want to find and remove the minimum number of parentheses so that the resulting parentheses string is valid and will return any valid string. And it's valid if it's an empty string and only contains lowercase letters, or it can be A and B, where A and B are valid strings. Okay, that makes sense. So let's just walk through an example for this one over here. We have a leet code, LEE, parentheses, TCODE, and this one, we want to be able to remove this one at the very end because in that case, it would fulfill the criteria as seen in this set of list over here. And it does that because it has all of the brackets have matching brackets on top of it, and the one that doesn't is removed. Same thing with this one, we want to be able to remove this one as well in order to produce this as a final result. And then this will also just produce like an empty string. Okay, that makes sense. Just to clarify, there's some constraints over here. You want to see that SI is either an opening bracket and a closing bracket, and it has to be a lowercase English letter. Okay, so what I'm actually thinking of doing is I'm thinking of having some sort of stack. So we want to have something where we create like a stack over here, and then we have a pointer which is starting at the very beginning. Now we want to keep moving this forward, and actually along with the stack, what we probably want to have also is some sort of data structure which contains the indexes of what we need to remove. So we can have like an indexes to remove data structure here. So from here, what we can do is we can take a look and basically add to the stack if it's an opening parentheses. So we keep moving forward. That's not it. That's not it. That's not it. Oh, okay, this is it. We want to add this one. And then we want to keep moving forward. We add another one. And then we keep moving forward. And then once we encounter a closing bracket here, we want to pop it off the stack here, right? Remove it from the stack if that stack exists. Otherwise, if the opening parentheses exists in the stack. Otherwise, what we want to keep doing is just keep moving on forward until we encounter another one, pop it again, and keep moving forward. And then let's say that we find a closing parentheses, but there's nothing in the stack that's actually open, right? Like there's like no elements in the stack. So if the stack doesn't exist at the time that this is happening, we're gonna add this as we're gonna add the index of this in terms of like what we need to remove. So we'll go ahead and just add this. The index is like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's say 12. Anyways, like the point is like we want to put the index as part of the indexes to remove. And then afterwards, what we can do is we can then iterate through every single item in the string again, adding it to a result value at the very end. And if it's if that specific index that we're iterating through right now is in the indexes to remove, we're going to want to skip that. So that's going to be pretty much the final result. The time complexity is going to be O of n, where n is every single character in the string. And the space complexity is going to be O of n as well, because worst case, we're going to be storing everything in the stack. You also have be storing basically maybe potentially everything in the indexes to remove set over here. So that sounds like a good solution. I'll start coding it up now. What we're going to have to do is we're going to create a stack here, and then we're going to create indexes to remove, and we'll just initialize this as a set. And then for every single value, or for index and value in the stack, what we're going to want to do is we're going to want to first check to see if not v is equal to an opening bracket, or not v is equal to a closing bracket. If it's not equal, or here, yeah, we'll make this an and actually. So if it's not equal to either of the two, we just want it to keep continuing because we don't actually want it to touch any of the letters. Now, what we want next is to check if the condition, if the value is equal to an opening parentheses, we're going to want to add it to the stack. So we want to do stack dot append, and then we want to append the let's say if we add the index and then the value over here. So we're gonna append that to the stack. Otherwise, we'll do if elif, and then we'll also have another check. Elif v is equal to a closing bracket, then we're gonna want to know, first of all, whether or not there's anything in the stack. So if stack exists, then we want to do stack dot pop. We want to pop that from the stack, right? Yeah, so we want to pop that from the stack. Otherwise, what we want to do is we want to do stack. We want to check to see. Well, like in this case, we're gonna know that there's gonna be nothing in the stack, so there's no parentheses to match it up with. So we want to add this as part of the indexes to remove. Indexes to remove dot add, and then I'm gonna want to add the index of the character that we're trying to add. Now, at the very end of this, what we're gonna want to do then is probably have a check, or let me think about this first. Yeah. Actually, we don't even need to add, the value. I'm pretty sure we can just add the index as part of the stack over here, because we're just checking to see, like, the only time we're going to be appending to the stack is if it's an opening bracket, right? So should be good. Next thing we're going to want to do is we want to loop through for v in stack. We want to do v like indexes to remove dot add the stack, so of everything in the stack. We'll go ahead and do add v, which is the index, right? The indexes of all the stuff that we want to remove. And now we're gonna have like a final result, and we're gonna want to iterate for index value in the sorry, not the stack. For index and value in the string, what we're going to want to do is we're going to want to check, is it in the stack? Like, so if index, or like if the index is in indexes to remove, we can just continue. Otherwise, we want to add that to the result. So we'll go ahead and do res.appends the specific value of like what we're iterating through. And then at the very end of that, we want to return the results joined together as a final string. So result.join res. So just to walk through this again, we're going to go take a look at this, and let's start off here with the L, the code. What's going to happen is the stack is going to start like populating, right? We're going to add, we're going to move this forward, continue, move this forward, continue, move this forward. We add a parentheses here, move this forward, continue, same thing here, and then we're going to counter a opening parentheses again, and then this is when we're going to begin to encounter closing parentheses. So at this one, because the v is equal to this, what's gonna actually happen is we're gonna pop this from the stack, and then what's gonna happen here is we keep moving this forward again. It's gonna pop this in the stack again, and then here we're gonna realize that there's gonna be nothing in the stack. So if the stack is if it's fulfilled, then we pop it. Otherwise, we add this to the indexes to remove, like we said, 12, and then it's going to check to see if there's anything in the stack that hasn't been popped, so we want to add that as well, but in this case, it's going to be nothing. So from here, we'll go ahead and loop through, check everything in the indexes is going to be 12, and it's going to skip that one as we enumerate through it, and then we're going to add that as the final result. So I think that sounds good. I'm going to go quickly just to go ahead and run this, check and verify it works. Run this, and everything is good. Thank you guys for watching.